Hello and welcome to the session. So, in the last session, we understood how to give a set of instructions to a computer and ask it to get a task done for you. Okay. In case if you guys have missed the previous session, do watch it and then continue with the session so it makes sense for you guys. Okay. Fine. Let's start with the session. So, what are we going to cover in this session? We are going to cover evolution of Java and its history and what is the need for Java when other high level languages like C and C++ were already there. Okay. Okay. We'll start with the session. So, evolution of Java. So, do you guys know what was the initial name of the application Java? So, initially it was not Java. So, James Gosling is a person and his team at Sun Microsystems. They found a language which was named as OAK first in 1991. Okay. And then later in 1995, it was renamed to Java. Let's see why it was renamed to Java and what was the purpose. So when they created this Oak first, okay, it was developed to use in embedded systems like remote controls, set-top boxes, and home appliances like microwave ovens. And later in 1995, okay, they renamed it to Oak and shifted focus to desktop and then web applications. So by then, um, Java is being broadly used in industry, and it is very popular. Okay, so when Oak was designed, their targeted consumers were electronics, okay, like TVs, microwave ovens, and remote controls, everything. Mostly they work with embedded systems. But then Java is used to develop web applications, mobile phones, and enterprise softwares, and Android as well. Okay. So this is the evolution and history of Java. So now let's see what is the need for Java when other high-level languages like C and C++ were already there. So the answer is need of platform independent language. So now what is a platform independent language? Let's see here with an example. Okay. So let's say we have a source code or high level language. So when I mean source code, it is the code written by us humans in high level language. Let's say we have a code written in C or C++, and we have a compiler, okay, probably a Windows compiler. When the compiler compiles the code high level language into machine code, that machine code can only be run on Windows platform. That machine code can't be run on Linux or Mac. So this is the issue. It is platform dependent. So for each platform, we need its own compiler. So for Windows, we need Windows compiler. So for Linux, we need Linux compiler and likewise for Mac. So we know what is compiler doing. Compiler is just converting our source code into a machine code which is understandable by the computer and the computer process the code. So this is the issue. So C and C++ was not platform independent. They were dependent on platform. Okay. So now let's see how Java solved this problem. Okay. So likewise in the above example, Java does work in the same manner, but slightly in a different way. Okay. So we write source code that is high level language. and Java compiler compiles the code to a byte code. Okay, that byte code can be run on any platform. So it can be run on a Windows or Linux or Mac. So it is little bit, if it is little bit confusing, let me again explain to you guys. See, basically, a high level language is compiled using a compiler to a machine code, and it will be run on a platform in a computer. So there is a little bit difference in Java, how Java works. Okay. So what we know that source code, high level language is convert using a compiler converted into machine code, that is a streams of zeros and ones. And then that machine code will be understandable by the computer and it will run the code. So in between this step, there is one more step, how Java works. So before converting it to a machine code, what Java compiler does, Java compiler converts the Java source code into a byte code. Okay. This byte code, humans can also can't understand and computers can also can't understand. Okay. So how the computers will understand this byte code? Okay. So this is the question. So let's say it. So when you install Java, right, in your Windows machine or Mac machine or Linux machine, so you install Java, okay, there will be something called JVM, okay, when you install the Java. So you don't have to understand what is JVM and everything. You just know when you install Java, there is something called JVM that is also installed in your machine for now, okay. So this byte code, okay, goes to the computer, and the JVM present in the computer will convert the byte code into machine code. That machine code is then understandable by the computer and runs the code. So when you install Java in any of your systems, Linux, Mac, or Windows, that particular platform dependent JVMs will be installed there. So Mac will have its Mac JVM, Linux will have its Linux JVM, and Windows will have its Windows JVM. What is JVM? It is the abbreviation is Java Virtual Machine. You know this for now. Later, we will talk about more about this topic. So this byte code can run on any JVMs. Okay. On a Mac JVM or Linux JVM or Windows JVM. And the JVM converts the byte code to machine code and it runs in the computer. So this is how Java solved the platform independent problem. So basically, we don't need separate compilers for Windows, Linux, or Mac here. It's just that we write the code, Java compiler compiles it to the byte code, and this byte code, it can be run on any platforms. It is platform independent. This JVM will automatically convert your byte code to the respective platform. So if it is a Linux platform, it will compile it to a Linux code, for example. It will compile the bytecode to a machine code, which is understandable by Linux computers. Likewise, Windows and Mac. Okay, fine. So hope you guys have understood how Java solved the platform independent problem. So let's quickly review what we have seen in this session. So we have seen evolution of Java and its history and why Java was needed. The answer is platform independent. And we we also saw how Java solved that problem. Okay, so that's all for this session. In the next sessions, we'll come up with a new topic. So until then, thanks and bye. Hello.